Hello, this question is from GATE 2017 and this is from the domain of classical mechanics. So the question states a uniform solid cylinder is released on a horizontal surface with speed 5 meter per second without any rotation, that is slipping without rolling. The cylinder eventually starts rolling without slipping. If the mass and radius of the cylinder are 10 gram and 1 centimeter respectively, the final linear velocity of the cylinder is dash meter per second up to 2 decimal places. So let us solve the problem. So if I make a diagram, this should be that let us consider this as a horizontal surface. Okay, and this is the cross section of the cylinder, and the cylinder actually moving in this direction, and it is uh, without any rotation, so it is actually slipping without rolling in this direction. Okay, and the speed is given as 5 meter per second. This is the radius of the cylinder, let be r. So the mass of the cylinder, let's say m, is 10 gram, and radius of the cylinder, which is r, is given as 1 centimeter, and the speed of the cylinder, that is v, is given as 5 meter per second. Okay, so let us calculate these things. So here the angular momentum about the point of contact is conserved. So we can write m u r equals to m v r plus I cm omega. So what is this? This should be, I have changed. So this is actually u, initial velocity or initial speed initially. So here ICM is the equal to moment of inertia of a solid cylinder about an axis passing through the or through its center of mass. Okay, and this should be equals to half m r square. Okay, and this omega is simply the angular velocity, and this should be equal to v upon r. Okay, which is the v is the final velocity. Okay, final speed of the cylinder, let's say. So let us put the values. I have given it small n, so let us small n. So it will be m u r equals to m v r plus r m r square times v upon r. So this will be cancelled. So this will give me m half mvr plus mvr. So 3 by 2 m v r. So if I cancel m and r from both sides, as both of them are non-zero quantity, then I will get u equals to 3 by 2 v. Okay, and the value of v is given as 5 meter per second. So it will be 3 by 2 times 5. If oh sorry, actually u is given as 5 meter per second. So this implies v equals to 2 by 3 u, which is equal to 2 by 3 times 5 equals to 10 by 3, which is 3.33 meter per second. So answer is 3.33. Thank you.